Welcome to this explainer. Let's jump right in. Today, we're unpacking one of the absolute most fascinating layers of modern AI development. If you've ever interacted with an advanced AI and thought, wow, how does it know exactly what I mean? Well, the secret sauce is what we can basically think of as the AI's brain, specifically vector databases. We're going to give you an A to Z guide of the top 10 open source vector databases that act as the crucial memory bank for today's AI systems.
So how do AI agents actually remember things? When you're building a Retrieval-Augmented Generation system, or RAG for short, or really any complex AI agent, it doesn't just magically hold the entire internet in its working memory. There's no way! It needs a hyper-fast way to instantly recall vast amounts of data to give you relevant answers. Okay, let's dive into this and figure out exactly how these massive data sets are processed, stored, and queried so that our AI systems can essentially think on their feet.
Here is our roadmap for today. We'll start with number 1, the AI context problem. Then 2, developer-friendly vector DBs. 3, heavyweight and scalable solutions. 4, integrated and niche platforms. And finally, number 5, deploying your AI stack.
Section 1, the AI context problem. Before we can really appreciate the solutions out there, we absolutely have to understand why AI models desperately need a totally new kind of database infrastructure to pull context at lightning speed. To put it simply, it's all about vector embeddings. This is the process of translating human data, text, images, audio, into high-dimensional vectors. You can think of these as incredibly complex arrays of numbers. Actually, a better way to picture this is like plotting concepts on a giant multi-dimensional map. Similar ideas, say dog and puppy, are plotted geographically much closer together than dog and car. This mapping is exactly how our RAG system knows which documents to pull to answer your prompt. As large language models grow, having a dedicated, highly optimized place to store and query these embeddings has become the absolute core of modern AI. It's literally how AI grasps meaning, not just raw text.
And this brilliantly illustrates the massive paradigm shift we're witnessing. Traditional databases rely on keyword-based search. They're great for finding exact word matches, sure, but they really struggle with semantic context. Throw a synonym at them and they might completely miss the mark. Vector databases are fundamentally different. Instead of looking for exact keywords, they perform a similarity search across those high-dimensional vectors we were just talking about. That means the AI models can retrieve contextually relevant information in milliseconds, matching actual concepts and meanings, not just strings of letters.
Section 2, developer-friendly vector DBs.
Now that we know why we need this tech, let's look at the first category in our top 10 open-source vector databases. We're focusing on tools that are absolutely perfect for rapid, agile experimentation. Number 1 on our list is ChromaDB. The crucial point here is that ChromaDB is incredibly lightweight. It was built specifically from the ground up for machine learning workflows and LLM-powered apps. It integrates seamlessly with popular AI frameworks, like LangChain and LlamaIndex. And that is a huge deal, because it totally removes the friction when you're prototyping new ideas. Plus, it supports both persistent and in-memory modes. The big takeaway? If you are building an LLM app, a RAG system, or an AI agent right now on your laptop, and you just want the easiest, most developer-friendly experience out there, ChromaDB is your go-to open-source tool for sure.
Section 3, heavyweight and scalable solutions. But what happens when your project graduates from your local machine? When you need to search through massive production-level data sets for thousands or even millions of users? That brings us to number 2, Milvus. Milvus is the heavyweight champion, engineered exclusively for production environments. It features this highly scalable distributed architecture built for massive similarity search workloads. We are literally talking about supporting billions of vectors completely seamlessly. It's even hardware optimized with GPU acceleration support, so things run blazing fast. Basically, when you're building an AI search system that needs to operate at true enterprise scale, Milvus is the robust infrastructure you want backing the whole shebang.
Section 4, integrated and niche platforms.
We've covered the lightweight option and the enterprise powerhouse. But what about the remaining 8 vector databases on our list? Well, these open-source tools have become beautifully specialized. So let's group them by their absolute best use cases to help you make swift, informed decisions for your architecture. Ready? Here we go. For purely high-performance semantic search, Qdrant is incredibly fast and optimized. If you're building complex knowledge graphs, Weaviate is amazing because it mixes vector search with structured filtering and GraphQL APIs. Then we have FAISS, developed by Meta.
This one is basically the grandfather of high-speed clustering for dense vectors, perfect when raw search speed across huge datasets is your main priority. Building a recommendation or ranking system? Vespa provides the specialized architecture for that. If you're running a Kubernetes cluster, Vald is native to that environment for highly scalable distributed search. We also have Elasticsearch, which now brilliantly supports hybrid search, mixing traditional text and vectors, which is a no-brainer if you're already in the Elastic ecosystem. Redis, a name we all know, brings its legendary in-memory speed directly to real-time AI vector indexing. And finally, if you just want to run vector similarity search right inside your existing relational database without spinning up a whole new engine, pgvector lets you stay completely within your PostgreSQL ecosystem. Keeping this specialized map in mind is absolutely vital for choosing the exact right tool for your project.
Section 5. Deploying your AI stack.
Now, theory and categories are great, but how do we actually put this into action? Honestly, setting up vector databases and the AI pipelines around them from scratch can be a massive headache. But you can completely sidestep those setup hurdles by using pre-configured virtual machines. Platforms like TechLatest provide ready-to-deploy VMs for environments like ChromaDB and Milvus, and they come out of the box with tools like Jupyter Hub already integrated. This means you can just instantly start experimenting with RAG workflows and embedding pipelines. It completely slashes your setup time, letting you focus on actually building your AI applications instead of just wrestling with infrastructure all day.
And to help make that experimentation even easier, there's currently an awesome initiative where eligible developers and orgs can access $1,000 in free Azure credits specifically to deploy these TechLatest cloud solutions. That's a huge practical pathway for teams to test out these sophisticated systems in a real-world cloud environment without breaking the bank. So how can you actually use those credits? Well, you can deploy your infrastructure with literally zero upfront cloud costs. You could spin up a private GPT deployment, for example. That's incredibly valuable for testing out enterprise data workflows completely privately, without ever sending sensitive info out to public models. You can also use it to launch general AI and LLM dev environments, set up cybersecurity labs, or build business intelligence stacks. It's just a fantastic, low-risk way to jumpstart your vector database experiments right now.
As we wrap up this explainer, I want to leave you with one final thought. As the adoption of large language models just continues to explode, vector databases are going to remain the absolute foundational technology, making smarter, highly context-aware apps possible. The tools are open source, they are powerful, and the infrastructure is easier to pre-configure than ever. So with all this infrastructure ready to deploy, what context-aware AI will you build next? Thank you so much for hanging out and learning with me today. Now take these tools and go build the future.